Hello friends, today we are going to see the load flow analysis technique of the 5 bus system network in the power system engineering discipline. In the power system engineering we have to do the load flow analysis or the mathematical approach of the power system network of the buses. We have three buses in a power system. We have slack bus, which can be used as the backup of the generator. We can use the slack bus, and also we have load bus and generator bus. The load bus, which is also called the PQ bus or the real power reactive power bus. In this side, the reactive power and the real power are known, but the unknown variables are the voltage and the shift angle of the generator. And also we can see the generator bus. In the generator bus, the real power and the voltage are known. There are two unknown variables, which are the reactive power and the shift, which is sigma. And in the slack bus, the voltage and the shift angle or the sigma are known, and the unknown variables are the real power and the reactive power. So in this lesson we are going to analyze the load flow by using Digsilent Power Factory Simulator tool. This simulation tool is very important for every electrical engineers, especially in a power system engineering discipline. So in this side we have 5 buses, and one is the external grid, and the 4 are the buses which are connected to the load and also in the transmission network. So in order to start our lesson in the Digsilent Power Factory, we have the Digsilent Power Factory 15.1 version, and we have just click file, then new and project. In this side we have this project, so click OK, and we have the grid. In the grid we can just go to the load flow or the basic data, whatever it is, just click OK, and we have just create our project. So we have 4 buses, and one bus again extra for the external grid. So in order to click the buses, just click bus. Here it is 1 bus, 2 bus, 3 bus, and 4 bus. Then click ASC. In the terminal of the first bus, we have just rotated to the external direction, like this, and the terminal again we have just rotated to the clockwise, the vertical direction. Also just to rotate it to the clockwise, again the clockwise, just click it and rotate it to clockwise direction, which is the vertical direction of the buses. And we have also one external grid. So in the external grid you can just click the external grid and connect it here. So in order to connect this external grid you have just to align the first bus, again just to align it. So we have just clicked the external grid, just click it here, and we have just connected here. Now it's created. So this is the external grid. So in the external grid we have this external grid load flow, and also we have a lot of things. So in the active power we have 10 megawatt active power, and the voltage set point in per unit is, in our case, just make it 1 in per unit. Then we have just click it, name, we can change it to, for example, bus 1, then click it OK. So we have 1 bus here. In the second bus we have bus 2, and we can check the load the basic data. Just click it, type new project type, and also we can change this name to bus 2, and the nominal voltage is 220 kV. Then click it, okay. Then the system type is AC, the phase technology is ABC, the line to line is 220, and we have just click it, okay. So we can also change the kV like this. So we have just continued to the bus 3, so we have bus 3, and also the line to line is in the bus 3 we have 132 because of the transformer. So we have just create the transformer first. We have to just create the transformer first. So in order to create the transformer, just click it, the transformer here, which is a double or two winding transformer. So you have two winding transformer here. We have just create it like this. We have just rotate it first. So in order to rotate this, we have to create it like this and like this. Now it's connected. So we can make it like this. Now we have two winding transformer. In the two winding transformer we can change the transformer like trafo 1 like trafo 1, and in the type, new project type, you can change the all rated power. The rated power for transformer 1 is 100 megavolt ampere. The nominal frequency is 50, and the rated voltage, the HV side rated voltage is 220 kV, and the LV side is 132 kV. Now is stepping down this voltage. So we are just create it like this, then click it OK. So in the second transformer in this side, so we have 132 kV. Now it is step down to 132 kV. So we have bus 3, and in this side we have another like transmission line. In order to create a transmission line, just this is a transmission line, so we have to create it like this. Here is the transmission line. In order to create the transmission line, here is the transmission line. We have the transmission line, we have transmission line data for the line 1. We have there are parameters. For example, the resistance in reactance value, so type, new project type, and also line type. We have just click it. For example, line 1, we have line 1, or we have just line 2, for example. So we have 132 kV. The rated current is, for example, 50.4. in our case 50.4. There is a cable type is the cable, system type is AC. The resistance ohm per kilometer, the resistance value ohm per kilometer, for example, we have make it 0.524, for example. In the reactance we have also 0.97 ohm per kilometer. Here it is the the values for the transmission line. So we can make it transmission line per kilometer. For example, length of the transmission line for the first one, we have make it 128 kilometer. So it is line 2 and make it okay. So transmission line 2 is created. In the transmission line, in the here we have just created two terminal, bus 1, bus 2, bus 3, and bus 4. In the bus 4 we have again 132 kV, 132 kV. So 132 kV again we have. So in this bus 4 we have bus 4, and again in the type of the new project type. So here is the bus 4, we have the nominal voltage of 132 kV. So we have just click it. Okay, now again we have another transformer here. So in order to create the transformer, again 2 winding transformer is here. Just put it here, connect it from line to line, bus to bus. So in this transformer, again it's 2 winding transformer. We have just said trafo 2. So this type, new project type, we have trafo 2. The rated power, for example, it is 50 MVA. For example, it's 50 MVA. The nominal volt frequency is 50. In the HV side, we have 132 kV. In the LV side, for example, let's make it 15 kV. And we have also the copper losses in kilowatts, because in the positive sequence impedance, no transformer has copper losses, because it's not ideal transformer. This is practical transformer. So we have the winding resistance. In the winding resistance there is a copper loss. So in the winding there is a copper loss. In the iron core there is the core loss. So in the short circuit voltage we have, for example, short circuit voltage for the first one, for example, let us say 10% or 0.1. In the copper losses of kilowatts, we have, for example, 9 kilowatt of copper losses. It's existed in the transformer. So we can make it okay. So again, make it okay for the transformer 1. Again, the same principle. For the there is the HV side. The HV side, we have the 220 kV. In the LV side, 132 kV. The short circuit voltage, for example, for the second one, we have 6% or 0.06. The copper loss, we have 6 kilowatt. For the for example 100 MVA we have. So this is trafo 1, example trafo 1. So the basic data we have just put the trafo 1 and just click it OK. So in this case there is a type, new project type. So we have just 220, 132 kV. There is 6% of the short circuit voltage, 6%, and the copper loss is 6 kilowatt for instance, and we have 100 MVA. Can make it trafo 1, then click OK. So we have the external grid, bus 2, bus 3, bus 4, bus 5. In this side we have 15 kV now. So we can just create the load, general load, by clicking the load here. We have one load, and also we have for example in this side 3 and 4 we have other load, and also we have another load here. So we have 3 loads for the general load. In the load data we can create the load data by clicking the load. Here is load 1, for example, load 1. Then click it, new project type, general load, type load. Here is load 1, AC type, 3-phase. Yeah, exactly. We can make it the load flow. In the load data we can make it the active power. For example, it is 1.5 5 megawatt, for example. So we have the which is the inductive load, in the power factor, for example, 0.96. In the reactive power, we can create the reactive power because we have the power factor 0.96 power factor. So in the power factor we have 0.96 power factor. So power factor means always, which is cos theta, which means cos theta. So cos theta means always, which is a power factor, which is always so power factor means P over S, or real power over reactive power. So in this power factor we have 0.96. So the P is 1.5 megawatt. So we can see the apparent power in megavolt ampere. So 0.96 times S over 1.5. So 0.96 divided by I mean 1.5 divided by 0.96, we have 1.5625 megavolt ampere, the apparent power. So apparent power means always which is P square plus Q square. S square equals P square plus Q square. So Q square means S square minus P square. So the reactive power is square root of S square minus P square. So 1.5625 times, for example, 2.44 minus 1.5 square. So we can calculate it by make it 2.44 minus 2.25, 0.19. So the square root of 0.19 will be 0.19 will be 0.435. So the megavolt ampere will be megavolt ampere reactive 0.4358. So we can make it like this. So click it. Okay, so in the load 2, this load again, its active power is 1.2 megawatt, and the power factor is 0.96, and the voltage, we have the voltage is 0.96, the voltage is 0.97. So we can calculate again the reactive power. So the reactive power will be 0.2828. So we can just click it. Okay, so we have the load 2, and in the load 3 again we have the active power. The active power is 0.85, and the voltage is 0.96, and the power factor is 0.94. So we can also calculate the reactive power. We have 0.307 megavolt ampere of reactive power. So we have just click it. Okay. So we have this type of the now we have just created 4 bus, including the external grid. So we can continue we can continue creating the 5th bus. So we have just removed this load. We can remove this load. We can remove this load and add another bus. So we can just create another bus here. So just again rotate it clockwise, then again we have to create the for example, we have just put the a transmission line, or we can just put the transformer here. Again, another transformer from here to here. So we can make the load again from here. So we have general load here, so we can continue to connect it like this. So it is possible to make this load. So in the third transformer we have the transformer 3, and the LV side, HV side. Again we have just create the type, new project type. This is transformer 3, and we have, for example, 20 MVA with 50 Hertz. So in the HV side we have 15 kV, in the LV side we have 0.4 kV. In the short circuiting voltage, let's say it is 3%, and the copper loss which will be 2 kilowatts, then we can make it okay. We can make it okay, and we have just create this terminal like bus 5, just by 5, just 15 kV bus, and we have just click it okay. So this is the whole system we have just creating. So again we have just created another thing likewise. So the same principle. So we can add another transmission line here by putting this transmission line likewise. So we can create another transmission line. In this case, let us talk about the more explanation about this transmission network loading capacity. What is the reason we have put the two transmission lines in this case? For example, there is load sharing, which means if the total loading capacity of the two transmission lines is for example 5% or 4%, then 2% loading will be for the first transmission line and 2% loading capacity for the second transmission line. If we disconnect one transmission line, then the 50% will be added to the existing network, and it will be full loading capacity, which means 4%. So in this case we can make the parameterization, so we can make it like line 3, and this is the type is new project type, line type, which is line 3, and the kV is 132 kV, in the kiloampere, which means 0.594 in this case, for example 50, and the AC resistance for the positive and negative sequence impedance is the 0.524 ohm per kilometer, and the reactance is 0.97. so we can click it then okay, and the kilometer will be 128 kilometer. So just click it okay. For the second, the same thing happened like before, 128 type, new project type, line type, which means 132 kV, the rating capacity 0.594, and 50 hertz, which is 0.524, and ohm per kilometer 0.97, and the line type is, which means line 2, and we can make it okay, then we can click it okay. So this is all about the transmission network creation we have. So again, in the trafo 1 we have HV side, LV side, bus 2 to bus 3. So we can run the simulation, this whole simulation, just by clicking the load execution method, and we can execute it. you can execute it. So this is the load flow analysis technique by using Newton-Raphson algorithm, and we can also see the results in the reports or the output calculation analysis, the reports section. So again we can execute it and go to the maximize output window, and we can see the reports one by one in the report of control condition for relevant controllers. So in this case we can see the MVAR, the megawatt losses, the line losses, how much is the line loss, 0.01 megawatt, in the external infill 3.56 megawatt. There are the MVAR values, and also we can see the how many iterations that the solution can be converged by the only two iterations that the Newton-Raphson algorithm can calculate the load flow. So friends, this is all about the today's lesson. I'm very happy to share with you the next lesson, which is in order to test the effectiveness of this software. Again, we can test by using electrical transient analyzer program or ETAP, and we can compare and contrast the values in comparison. So don't forget to like, subscribe, and share with your colleagues. So it's very important to upload next videos to you. So until next time, happy weekend, happy time, and I'm pleased to share with you quickly. So thank you very much guys. Thank you. Bye.